This video is to talk about how to reduce signal flow graphs. In particular, we use Mason's gain rule. All right, let's highlight that, which says that y over r, or my input. So let's say, for example, I have some signal flow graph and it has an input r and an output y, and I don't actually care what's going on in between. It could have loops, it could have forward paths, etc. All right, so I might have some signal flow graph, but the relationship between y and r is 1 over delta sum over k of p sub k delta sub k, where k is the number of forward paths, p sub k is a specific forward path, delta is equal to the determinant, and it's equal to 1 minus the sum of the individual loop gains. That means gains of every single loop that exists in the signal flow graph, plus the sum of gain products of two non-touching loops. So what you do is you find every loop that does not touch and you multiply them together. And then if you have 3 non-touching loops, then you would subtract that out and continue on for 4 and 5. Okay? Now, probably most problems that you would see at an undergraduate level would be within the first 2 or 3 of these. So I've used dots here to do that. And then the last thing we need to know is that delta k, or delta sub k, is just delta, but with all the loop products that touch pk removed. So if I have one path and all the loops touch it, then delta sub k is going to look like 1, because all of the gains that touch it have to be removed. All right, so that's a very simple reminder of how to use Mason's gain rule.